Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hai, Assalamualaikum warahmatullahi wabarakatuh kepada semua para guru, ibu bapa dan anak-anak pelajar sekalian. Selamat datang ke Pusat Tuisyen Akademi Youtuber bersama Inertia Malaysia dan juga Kelab Guru Malaysia. Bermula percuma, selamanya percuma. Jadi sebelum kita mulakan kelas pada petang ini, marilah kita membaca umul kitab Al-Fatihah. Untuk yang bukan Islam, bolehlah bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Okey, apa khabar adik-adik semua? Cikgu harap semua berada dalam keadaan baik dan bersedia untuk meneruskan kelas kita pada hari ini. Cikgu percaya adik-adik semua dah tak sabar untuk meneruskan kelas kita kali ini. Jadi cikgu perkenalkan diri cikgu dahulu. Nama cikgu Izyan binti Saleh dari SMK Teluk Palma Garang Selangor. Boleh panggil Cikgu Izyan selaku moderator pada petang ini. Okey, pada petang ini kita bersiaran secara langsung dari channel Mr.Peh. Siapa yang belum subscribe, silalah tekan butang subscribe sebagai tanda sokongan kepada Mr.Peh. Nama sebenar beliau adalah Peh KH dari Kolej Tingkatan 6 Tun Fatimah Melaka. Kita hari ini akan mempelajari tajuk 2.4 Inertia dan kelas ini akan berlangsung lebih kurang 1 jam lah. Okey, selain itu kita ada Cikgu Yani dari SMK Bandar Bitulu selaku control host. Okey. Jadi sebelum kita teruskan kelas kita, cikgu ingatkan semua pelajar dan penonton yang ingin menghantar komen untuk menggunakan bahasa yang sopan dan gambar profil yang bersesuaian untuk tontonan umum. Okey, jadi cikgu percaya semua yang hadir kelas pada petang ini merupakan pelajar cemerlang. Okey, jika anda ada apa-apa soalan, boleh terus tanya di ruangan komen. Okey, link sijil akan diberikan pada hujung siaran nanti. Pastikan diisi dalam tempoh 30 minit selepas kelas tamat. Link sijil hanya dapat diisi dengan email e-didik, MOE, MyGuru dan Jawi sahaja. Okey, jadi cikgu harap sila fokus pada isi pelajaran yang akan disampaikan oleh Mr.Peh. InsyaAllah moga kelas kita pada petang ini dapat dimanfaatkan sepenuhnya oleh para pelajar. Okey, jangan lupa share pada kawan-kawan, ajak kawan-kawan untuk ulang kaji hari ini tajuk Inertia. Jadi tanpa membuang masa lagi, saya serahkan kelas kita pada Mr.Peh. Silakan.
Okay, so thank you kepada moderator Cikgu Izyan. So saya juga hari ini ada Jaing dekat chat room. Okay, so welcome Jaing. Okay, lama tak berjumpa. Dan sini ada Sabrina lagi. So welcome to join my class. Okay, so ini merupakan iklan untuk kelas AYU, kelas Fizik. Okay, di sini kita ada 2 kelas, kelas tingkatan 5 diadakan pada setiap Jumaat 9.30 malam. So kini kita sudah sampai tajuk 2.2 tekanan atmosfera yang disampaikan oleh Cikgu Rosemawati. So sekiranya anda miss out kelas tersebut, bolehlah visit kepada channel Cikgu Rose supaya kamu dapatlah follow kelas tersebut. So satu lagi kelas seperti hari ini adalah kelas tingkatan 4 dan kita adakan pada setiap Ahad pukul 3.30 petang. So hari ini disampaikan oleh saya lah, Cikgu Peh. So ini merupakan panitia Fizik SPM Akademi Youtuber Malaysia. Dan hari ini bersama saya pada petang ini ada Cikgu Izyan dan juga Cikgu Yani. Terima kasih cikgu-cikgu mengikuti bersama saya pada petang ini. Okay, so saya Mr.Peh kini mengajar di Kolej Tingkatan 6 Tun Fatimah Melaka. Tajuk yang saya akan sambung pada hari ini juga bab 2 iaitu Force and Motion 1. The subtopic for today's lesson will be 2.4 Inertia. Okay, so for today's subtopic, we have total 3 learning standard you are going to learn. The first learning standard will be explain the concept of the inertia through examples. So firstly, what is the inertia? So from the sentence showing the slide here, inertia is a tendency of an object to remain at rest, or if moving, it will be continue its motion. So this is the definition. So that means the object, if let's say in the rest condition, will remain at rest. If in the moving state, will be continue in moving state. Okay, so the inertia is related to the Newton's first law of motion. So where the Newton's first law of motion state that object will remain at rest or move at uniform velocity if no external force acted upon it. So later on, we will discuss few examples where the activity you can do at your home. So inertia is not a physical quantity, so that means the inertia is not able to measure. So here, we have few activities involving the inertia. So firstly, the activity is in the original state of object that is at rest. So that means that we can classify the activity of inertia to 2 situations. The first situation will be the original state of the object is at the rest condition. Okay, so here, example 1, when a cardboard is quickly put away, the coin drops straight into the glass. So you can observe at the GIF here. So when we remove the cardboard faster, so the coin will be dropped to the glass and not follow the cardboard. So why? So because the inertia of the coin maintains it in rest even when the cardboard is withdrawn. Okay, so that means as per mentioned just now, the definition will be the object will be remain in the original state. So here the coin original state is rest, so will be continue rest although the cardboard is removed. And the second example will be a book is pulled out from the center position. Okay, you can look at the figure here. Okay, so the books on top will straight downward. Okay, so that means here the books on the top will be not follow the moving condition. Okay, so explanation, inertia try to resist the change from rest. That is when the book is pulled out. The books on the top not follow suit. So that means the book here at the top will continue in original state, which is in rest condition due to its inertia. Okay, so the second situation will be the original state of object is in motion. So that means if I say we follow the definition of inertia, the object will continue in motion. Okay, so here the water droplet on the wet umbrella. So you can see at the figure. When the girl rotate the umbrella with a certain stop, so that means the water droplet on the umbrella will be dropped when the rotating umbrella given a certainly stop. Okay, so why? This is because the water droplet on the surface of the umbrella move simultaneously as the umbrella is rotated. So that means in the theory of the inertia, if the object is in motion, so it will continue in motion, although the girl is given a certain stop to the umbrella here. Okay, so when the umbrella stopping rotate, the inertia of the water droplet will continue its original motion. So the original motion here will be rotating. So that means the water droplet on the umbrella will be continue rotating, although the umbrella already stopped due to its inertia. So this is an example for situation 2. Then the second example for the situation 2 will be tomato sauce is easier to pour by shaking the bottle and stopping it suddenly. So you can look at the figure. So the bottle is given a fast downward motion initially, okay, and then give a certain stop so that the sauce will be continue moving and drop from the bottle. So the explanation will be the sauce in the bottle move with a bottle during the downward motion. So be here. This is the inertia. So the sauce and the bottle will be in the same motion. So the speed will be the same. So when the bottle is stopped suddenly, the inertia of the sauce causes it to continue in its downward motion, movement. So thus the sauce is pulled out of the bottle. So that means when the bottle is stopped, the sauce will continue its motion and drop from the bottle. So this is an example for situation 2. Okay, so now we go to our second learning standard, which is experiment to identify the relationship between the inertia and the mass. Okay, so here we have 2 experiments which we want to study the relationship between the mass and the inertia. Okay, so the first will be using the pill together with sand. So this is a procedure. 2 empty pills which are hang with rope from the ceiling. So with these 2 now. So one pill is filled with sand. So you can look at the figure. Okay, so this pill is filled with sand while the another is empty. So that means the mass for, okay, let's say here we have A and B pill. So the B pill will have greater mass compared to A due to the pill B is filled with the sand. Then both pills are pushed. So initially both is in stationary. So we give a external force. Okay, so the movement you need to observe and record. Okay, after that, when both pills are oscillating and an attempt is made to stop them, then after that, when they are in oscillating or in motion, so we try to stop it and we observe again and recording. Okay, so here we have 2 observations. The firstly will be the pill initially in rest condition and we try to move it. And then the second one, when both pill is oscillating, we try to stop both of the pill here. So we want to see which of the pill is easier to move or easy to stop here. Okay, so what's the observation we expected? So here will be the pill filled with sand feel more difficult to move and to stop moving than the empty one. So here we see that for the first 3 steps, where we want to see the pill from the original state, which is rest to motion. So B showing that it is more difficult to move due to greater mass here. So that means the pill B, which has the greater mass, try to continue in rest condition or try to remain in rest condition here due to it has a greater mass, which is showing that it has a greater inertia here. Okay, so explanation, the pill filled with sand has a greater inertia or mass than the empty one. So B will be showing a greater inertia due to it is filled with the sand. So conclusion, the larger the mass, the larger the inertia. Okay. So here, second experiment will be one of the compulsory experiment in Form 4 syllabus. So this is the experiment in your textbook, page 53 to 54. Okay, so the experiment is to study the relationship between inertia and the mass. The manipulated variable will be the mass of the plasticine. Okay, so you can look at the material, the plasticine of the mass 20, 30, 40, 50, and 60. So here we have 5 reading, so which is actually the manipulated variable for this experiment. And then responding will be period of the oscillation. So that means the longer time for the plasticine to oscillate, so it will be showing greater inertia. Okay, so that means the responding variable, actually we want to see the inertia, which is measured by period of oscillation. Okay, and then the constant variable will be the distance between the G gap here to plasticine. So where here showing 20 cm must be always the same here for this experiment. So procedure: set out apparatus as shown in figure 2.44 here. Fix a piece of 20 gram plasticine to the free end of the jigsaw over here. Deplace the free end of the jigsaw blade horizontally and release it so that the plasticine oscillate. So that means we will be pulled to here and then we release so that the plasticine or the jigsaw will be vibrate horizontally. Okay, so here we want to record the time taken for 10 complete oscillation. Then we repeat step 3 and 4 for others mass of plasticine, which is 30, 40, 50, and 60 here. Okay, so then you record, then we get the period oscillation, then we plot the graph t squared against m. Okay, so what is the conclusion for this experiment? So will be the larger the mass of an object, the larger the inertia, where measured by the period oscillation, which is taking more longer time. Okay, so here I'm going to discuss with you one example question of paper 3 question here. Okay, so this is an example of tugasan amali berbantu. So if I say you have followed my previous lesson in chapter 1, so actually I introduced to you all the example of the paper 3 already. So we have 2 types of the tugasan, which is amali, tugasan amali berbantu dan tidak berbantu. So for amali berbantu, the procedure will be given. So that means in this example of the paper 3, the procedure will be given. So you just follow the procedure and conduct the experiment. Okay, so let us read together the question. So you are not allowed to work with apparatus in the first 5 minutes. So for paper 3, the time duration will be about 45 minutes. Okay, so 5 minutes will be let you to check the apparatus and read the question. Okay, so this period is used to check the apparatus list, read the question, and plan the experiment with which is carried out. So mark the box provided to check the material and apparatus prepare and supply. So firstly, you have to check whether the listed apparatus and material is already in your, maybe in the box already lah, okay, for conducting the experiment. So here will be plasticine with different masses, then G-clamp, hot saw blade, stopwatch, and meter rule. Okay, if I say you check already within the 5 minutes, so you just tick lah, and then you straight away you go to read the question. Okay, so the question will be like this lah. You are required to carry out the experiment to study the relationship between the mass of the plasticine and its period of oscillation t. So which is related to the experiment 2.2 here lah. Okay, so you have to identify the MV and RV for this M Okay, so here the mass of the persistent will be MV, and then the RV will be period of oscillation, which is indicate the inertia for the object. Okay, so step 2, you have to read procedure and the diagram given here. So we normally need about 5 data, okay, for plotting the graph. Okay, so here the question, carry out the experiment by using the step below. Arrange the apparatus and material is shown in diagram 1. So with this now. So attach the ball of the plasticine with the mass of 30 to the loose end of the hawk saw blade. So be here lah. Move the saw blade to one side and release. So which is actually same as the experiment in the textbook. Just now I show you already. Okay, and then record the time taken for 10 complete oscillation here. And then we repeat the experiment with the different mass here. So total we have 5 reading of manipulated variable. And then we record the time taken for each mass of participant here. Okay, so the first will be 30 gram. And then you have to take your first RV here lah, for 30 gram oscillation. Okay, and then this is the others 4 MV here. And you have to record the another 4 RV lah. So that means total you have 5 MV and RV for this experiment. Okay, so now let us look at the diagram here to show how you conduct the experiment. So you are advised 20 minutes to complete the experiment. Okay, so here you need to know the smallest division for your stopwatch. Okay, so for example, for this stopwatch, okay, so the smallest division is 0.01 now. Maybe it's very small already lah. Okay, so we just assume that the smallest division for this stopwatch will be 0.1 second lah. Okay, so the smallest division will be depends on your apparatus. Okay, so for 30 gram, so for 10 oscillation we get 10.8 lah. Okay, and then 40 gram we get about 12.9. And then we have others also lah. 50 gram we get 14.6. Then 60 we get about here, right? So it'll be 15.9. Then the 70 gram we get about 17.5 gram. So after you conduct the experiment, okay, so we will recording all the 5 MV and RV, and then we straight away go to the question. So the question here, based on the experiment conducted, you are required to state the manipulated variable, responding variable, and constant variable. So just now I already show you the manipulated variable able to get from the question, which is the end of this experiment. So it will be the mass of the participant. Okay, so answer will be mass lah. And then the second will be responding variable. So will be we measure by using the stopwatch, which is the period of oscillation. Okay, so answer will be period of oscillation. And then the constant variable will be the distance of the jigsaw between G clamp to plasticine. Okay, length of the blade given here lah. So answer will be this lah. Okay, then the next, the B, tabulate the result for all value MT, T, and T square in the space below. Okay, so the question asks you to tabulate these 4 parameters. Okay, so from the experiment, we can get M and T. Okay, so with this 30, 40, 50, 60, 70 is given by the question. And then the T, small letter T here is a 10 oscillation. Okay, time taken for 10 oscillation. And the decimal here will be 1. which is follow the smallest division of the apparatus or the sensitivity of the apparatus lah. Okay, so in your table, firstly, you need to give the symbol or parameter. So here the M showing that this is a symbol for mass lah. Okay, so small letter t for 10 oscillation, time taken for 10 oscillation, and then capital T will be time taken for 1 oscillation. So you need to divide by 10 lah. So you get 1.08. Or later on I show you the answer. So second, you have to give the unit for each parameter here. Okay, so and then the third, make sure you get consistent decimal point here. So for example, 10.81 decimal place. So the second until the end, the data must be showing the same decimal point here also lah. Okay, so as I mentioned just now, the capital T will be time taken for one oscillation. So we divide by 10, so we get 1.08. So the secondary data here can maintain with 2 decimal places here, but make sure the others data here will be also showing the same decimal places lah, which is 2 here. So we get 1.29 and others. And then for t square, so we will be square the value of 1.08 here. So you get 1.1664. So you can give your answer in 2 decimal places lah. Okay, and again, make sure all the data showing the same decimal places. Okay, so you will get 6 marks if I say you fulfill this all criteria I listed here. Okay, then the next will be plotting the graph, 3 mark here. So on the graph paper provided, plot graph of t square against m. So that means the y-axis will be t square, then x-axis will be m lah. So this is the data which is needed for the graph in question C here. So firstly, you have to give symbol for both axes, unit for both axes also, and then third, we have to give the correct scale. So how to give the correct scale? So you need to identify the maximum and minimum value from your data. So you can see the length will be 30 and maximum will be 70. Then t square, the minimum value will be 1.17. The maximum value will be 3.06 here. And the scale selected, actually I discussed in chapter 1, section 1.2 already. Okay, so we need to choose multiple 1, 2, 5, or 10 only lah. Okay, so will be like this lah. So you can see the axis X 10 to 70 is covering the maximum and minimum value already. And then the y-axis here 0 to 3.5. So the maximum reading and minimum reading is covering already. So that means the third criteria is met lah. Then the fourth, you have to make sure the graph you draw, the size must be greater than 4 unit times 5 unit. So here will be 1 unit. So that means your graph must be minimum 4 times 5. So it'll be about half of the graph. Okay, and then you have to identify the smallest division for each axis. So you can see from this y-axis, the one smaller box here will be 10 divide 10 box. So it'll be 1. Okay, and then for y-axis will be 0.5 divide 10, you get 0.05. Okay, so you can start plotting the graph. So the first reading here, 30, the x-axis will be here. Then the y-axis 1.17, you can divide with 0.05. Okay, so you can round off first lah. Okay, you can round off first to 1.20 here, because the smallest division only 0.05. So we are not able to draw 0.07. So we round off. Okay, so the first reading will be here. About here. You can use 1.2 divide 0.05. So you know there is how many boxes you are going to plot here. So the second reading you can round off. And again, you can plot your all 5 data here already lah. Okay, so make sure your point all is correctly. And then draw the baseline. So what is the baseline? Actually, I also discussed detail in last previous video already. Okay, section 1.2. You can have a look, okay, for the discussion. Okay, so basically, the upper point, the line here, the upper point, the point up of the line, and the point below the line, difference must be less than 1. So here you can see these 3 points is on the line, and we have 1 point below the line, and 1 point upper the line. So 1 minus 1 will get 0. So that means this is considered as a baseline already lah. Okay, so this is what we can get full marks if let's say you fulfill these 6 criteria I discussed here for plotting the graph. Okay, the question D, state the relationship between 3 square and m. Okay, so for this one, you can see the straight line is passed through the origin. So we also already learned in subtopic 1.2. So this relationship will be directly proportional. Okay, so total 1 mark you will get. The last will be the gradients. Okay, so how we get the gradients from the graph? So here you need to draw the triangle. So the triangle must be big enough lah. Okay, so how big? The size I already discussed in subtopic 1.2 also. So this is the first mark. You have to show the line and the right angle. So here we get 2 points. So we're using the gradients formula you learned in P3, y1 minus y2 divide s1 minus s2. So be this. So you get the answer 0.041. Make sure you give the correct unit. Okay, so here the y is s squared. Then the x will be gram. So you get this unit. Okay, so that's all for discussion for paper 3, which is actually 15 marks. Okay, so Cikgu Izyan, we can have a break first.
Okay, kita rehat sebentar. Jangan lupa kembali selepas ini.
Tuisyen online percuma. Tuisyen online percuma. Layari www.Akademi Youtuber bagi mengikuti tuisyen online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi Youtuber. Rujuk jadual di laman sesawang www.akademiyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuisyen online percuma mestilah Akademi Youtuber.
Okey, kita kembali. Kita belajar tentang eksperimen. Okey, nanti Mr.Peh akan teruskanlah. Dipersilakan Mr.Peh.
Okay, so terima kasih Cikgu Izyan. Okay, so we continue to our last learning standard 3. So you need to justify the effects of the inertia in everyday life. Okay, so inertia in everyday life here will be example just now I already give you 4 activities which is related to the activity involving inertia. So here I discuss again now, okay. So here we have 2 situations also. The first will be the original state of the object is at the rest condition. Okay, so here you can see the balloon is actually initial at the rest condition. Okay, so the balloon at the back of the bus will jack backward when the bus accelerates suddenly from rest. So initially the balloons is in rest. When the bus accelerates from rest condition, so you can see the balloon is jacked backward. So here is a key observation you need to identify. Okay, so the inertia of the balloons makes them remain their state of rest. Okay, so why the balloon will be jacked backward? Because its inertia make them remain in the rest condition lah. Okay, so the second situation will be the original state of object in motion. So here you can look at the driver. Initially is at the motion, and then when the car suddenly stop, you can see the head of the driver is thrown forward. Okay, so why? So inertia of the driver assists the change of the motion. As a result, the driver continue to move forward. So that means that initial, actually we have only two situations. The situation one will be from rest condition to motion. Okay, so you can see the observation will be the object will be jacked backward because its inertia trying to remain in rest condition. Then the second will be the object in motion and trying to stop. Okay, or decelerate also can now. Okay, so the observation here will be the object will be thrown forward. Okay, so this is only two observation for two situations here. It's very easy actually for this subtopic. Okay, so as I mentioned, for the object from rest to motion or accelerate accelerate. So the object will be jacked backward. Then the second will be when the object in motion trying to stop or decelerate. So the observation will be the object will be thrown forward. Okay, so because of this inertia, they can actually bring positive and negative impact to our daily life. Okay, so now let us discuss the positive effect of inertia first. Okay, so firstly, here you can see this is a sumo wrestler who has a greater mass, also has a greater inertia. He is harder to be toppled down. So that means for this competition, okay, so we preferring the person who has a greater mass, because the greater mass will be have the greater inertia, so will be not easily to fall down by another person. Okay, so this one you can imagine. So a person which has the less mass and trying to move another bigger object. So you can see the elephant will be continue in rest. Okay, and not easily to be fall down by the object or a person who has a lower mass and given a low inertia. Okay, then the second here we discussed just now. Okay, so the positive impact will be tomato sauce is easier to pour by shaking the bottle and stopping it suddenly. The third also we already discussed just now. So drying off the umbrella by opening and closing it quickly. Then the fourth positive impact here will be to tighten a loose hammer. Okay, so here you can look at the figure now. So we initially have a fast downward motion, which is same as the bottle here. Okay, and then when the hammer hit a hard object here, so the hammer will be stopped suddenly, but the head of the hammer will continue moving down, so that will be able to tighten by this way. Okay, so this is application of the positive impact of inertia in our daily life. Okay, and then here will be the negative impact. Okay, negative impact of inertia. Okay, so firstly, I think most of us who has experienced taking a bus, okay, so we will feel uncomfortable if I say the driver drive very fast and then decelerate suddenly or accelerate suddenly. Okay, so why? So as per mentioned just now, when the bus suddenly move forward or accelerate from rest, so the inertia of the passenger body tends to keep them at rest. This causes the body to throw backward. Okay, and in other condition, the passenger are in state motion, still motion, when the bus is moving. Okay, so when the bus suddenly stop, the inertia of the passengers tends to continue in its forward motion. This causes the body of the passenger throw forward. Okay, so that means if I say the bus accelerate suddenly, so the person will be throw backward. Then suddenly, as decelerate, we will be throw forward. Okay, so this is a uncomfortable feeling. Okay, if I say our driver cannot drive consistently, right? Okay, and then the second will be cause the serious injuries for passenger and driver during accidents. So here we have 3 cases. Okay, so the passenger in lorry, which is in figure A, car driver in figure B, and the motorcyclist at figure C. You can see they are jacked forward when their vehicle stops suddenly. Then the third negative impact of the inertia will be a heavier vehicle will take a longer time to accelerate or to stop. Okay, so first you can look at the figure here. So massive oil tanker will be this now, or very big ship take a long time to accelerate to its full speed compared to the smaller ship here. Okay, so this is first negative impact in this figure. Okay, and then the second, you can look at the figure. So the ship is not easy to be stopped due to its larger mass and larger inertia. Okay, so a few kilometers to come to stop, even though the engine has reversed in propeller to stop it down. Okay, here the third figure will be comparison between the lorry and the car. So the lorry has a larger mass, will have a larger inertia. So that means the moving lorry will be difficult to stop compared to car. Okay, so the moving track is harder to stop compared to moving car. So in conclusion, the heavier vehicle will take longer time to accelerate and also to stop. Okay, so this is a negative impact for the inertia in our daily life here. Okay, so since we know that the negative effect of the inertia can cause serious injuries or death to the passenger, driver, and also others. Okay, so how we can try to reduce the negative impact of the inertia? Okay, so firstly, from this figure, you can see there is 4 tanks. Okay, so 4 tanks with distributed mass will have smaller inertia. So that means if I say we're using a one bigger tank, is actually have more back effect to the driver or passenger if the accident is occur. So to reduce the inertia, so we can try to using the smaller tank. Okay, so that the inertia will be smaller. Okay, so this will greatly reduce the initial impact on each tank if the tanker stops suddenly. Okay, so this is the first where we try to reduce the negative impact of inertia. And the second actually is the same. The ship should use more oil tank to reduce the inertia. So you can see the oil tank is separate to few smaller tanks here. So it's actually want to reduce the inertia. And the third one, furniture carried by lorry is normally tied by rope here to certain fixed parts of the lorry, so that when the lorry move or stop suddenly, the furniture will not fall or will not be thrown forward. Then the last here will be the safety in a car to reduce the negative impact of inertia. So the first feature here will be safety belt. Okay, so a safety belt in the car secure a driver to his seat. When the car stops suddenly, the seat belt prevents the driver from being thrown forward. Okay, then the second, fixing the airbag here. You can look at the figure. So the airbag will prevent the passenger from hitting the dashboard. Because as per mentioned just now, when we have a suddenly stop of a moving car, so the driver or passenger will be thrown forward. Okay, so will be able to hit the dashboard and cause serious injuries. Okay, so the airbag is used to prevent the passenger to hitting the dashboard. Okay, then the last feature related to the negative impact of inertia will be headrest. Okay, so we're fitting the headrest here is to prevent the injuries to the neck during rear end correction. So the inertia of the head tends to keep in the state of rest when the body is moved suddenly. Okay, so this is three feature of the car which is related to negative impact of inertia. Okay, so there is actually more feature can be seen in your car to reduce others back impact. For example, for next subtopic 2.7, okay, we can have the others safety feature of the car to reduce the impulsive force. Okay, so here we have actually finished all the three learning standard. Okay, so here I have another three questions here related to this subtopic. Okay, so the first question here will be the SPM 2015 examples. Okay, so diagram 1 shows a man checking a tablecloth. Will be here now. The glass remain on the table because of inertia. So which action increase the inertia? Okay, as per a discussion in learning standard 2, okay, so the inertia is directly proportional to the mass. So that means if you want to increase the inertia, you can increase the mass. Okay, so how we can increase the mass? So here, the option A, use a rougher clothes is not related to increasing the mass. Using a smoother clothes also. Pull the clothes with greater force. So the force is not related to inertia according to the discussion just now. Okay, so the mass is increases, then the inertia will be increases here. So that means the glass fill with the glass with more water. So when we fill the glass with more water, so there will be increase in mass. So the inertia will be increased also. So the answer will be D. Okay. Then the next question is example question of the 2018. Okay, so diagram 3 shows two identical tops. So we have two tops F and G here. Several pieces of aluminium are placed on the top of G. Okay, so you see G, we have few pieces of the aluminium. Okay, so both tops are then spun simultaneously. So what is the concept causes top G to take a longer time to stop? So again here, when we adding the pieces of aluminium, we are actually trying to increase the mass of the top G here. So the initial will be also increases lah. So it's actually applying the concept of inertia. So when the object is in greater mass, which will be have the greater inertia here. So the moving object will be continue moving for more longer time due to its inertia, try to continue its motion. Okay, so increase mass of the top G, okay, because of the piece of aluminium. So the initial will be increases. Okay, so the larger initial make it continue its state of motion for more longer time. So the answer here will be B. Okay, so we go to the last question. Question 4 is an example question for paper 2, section A, the type question of multiplication. Okay. Okay, so let us read the question together first. Diagram 6.1 shows an apparatus arrangement for experiment to determine relationship between the mass and the inertia. Okay, so this is the experiment we discussed just now. Okay, so we have two empty can here. Okay, so the A will be empty, then the B here will be together with the sand. So that means the B will be have a greater mass, which will be showing the greater initial. So the pure B here will be difficult to move from the rest condition or more difficult to stop in the motion state as per mentioned just now. Okay. So firstly, what is the meanings of inertia? This one you can straight away get from the first sentence in the first line. So which is tendency of the object to remain at rest, or if moving, will continue its motion. Okay, so this is two keyword here. Then the B, the pupils found that it is more difficult to move a can filled with sand, okay, compared to empty can. Which can is harder to stop? Okay, so as per mentioned just now, the initial is actually direct proportional to mass. For the bigger mass, it will be have a greater initial. So the greater initial will be difficult to move from rest condition together with also the condition where they are in motion will be continue in motion. So will be more difficult to stop. Okay, so will be B lah here. Okay, can fill with sand. First mark. Okay, because it has larger.
Banyaknya hadiah menarik menanti anda.
Okay, so because it has larger inertia, or you can give larger mass here. So will be second mark. Okay, so the next will be diagram 6.2 shows an oil tanker truck. So here you can see there are three small tanks here. Okay, as per mentioned just now, why we want to have a smaller tanks? Because we want to have a smaller initial. Okay, because we know that the big initial will be able to bring a back impact to our daily life. Okay, example, serious injury to the driver or also the passenger. Okay, so propose modification to the truck so that the oil can be delivered safely to location based on the following aspects. So here the first numbers of the tanks, small tanks must be more, right? Okay, so that the initial can be reduced. So the track can able to stop or move more easily compared to using a one bigger oil tank here. So the answer will be more. Reason is to reduce the inertia. Okay. Then the second question here, distance between the track head and the tank. So we here lah. Okay, so as per discussion, okay, if I say the movement track certainly stop, so the tank will be thrown forward. Okay, so that it's better to have a greater distance. Okay, so that the time for the tank to collide the head of the track will be taking a more longer time. So we prefer larger distance. Okay, so that we can extend the time of impact. So that means the tank will be take longer time to reach the head of the lorry here. Okay, so another answer can be prevent collision between the tank and the truck head. Then the last will be load limit. Okay, so what's the load limit? Okay, so the load limit here you can observe for this figure. So we have two load limit here. The BDM referring to the berat dalam muatan. Here, berat dengan muatan. So that means the maximum lorry able to carry the things will be 9,300 kg. Okay, cannot be exist of this amount. And then here BTM will be berat tanpa muatan, 3,500. Okay, so why we need to have a load limit? Okay, as per mentioned, just now you guys say we have the greater mass, so it will be have a greater initial. So the lorry or the heavy vehicles will be more difficult to stop. Okay, so that here we need to have a smaller load limit so that the initial can be reduced. So the back impact during the accident can be also reduced. Okay, so the answer will be, okay, so the hot test here will be initial depends on mass. Higher mass, higher initial. So it is difficult to stop a moving lorry which is carried by big load. Okay, so that means here we want to have a smaller load limit. So reason we want to have a smaller initial. Okay, so this is an example question for paper 2, question type of modification. Okay, so that's all for my sharing today. Okay, I pass back to moderator Cikgu Izyan.
Okay, terima kasih Mr. Peh. Okay, selesai kita pada kelas pada petang ini. Jadi cikgu nak ucapkan tahniah kepada semua yang setia bersama kelas pada petang ini dari awal sehingga akhir. Okay, cikgu tengok ada Cia Ying, Cia Yao, okay, dan lain-lain. Mungkin soal tajuk hari ini agak mudah kan, tak ada soalan nak tanya. Okay, jadi sebelum kita tamatkan sesi secara langsung, bolehlah tutup ruangan chat dan klik butang subscribe untuk yang belum subscribe dan aktifkan ikon loceng supaya tak terlepas untuk sesi kelas yang seterusnya. Okey, jika anda suka dengan apa yang kita pelajari hari ini, boleh klik like dan share kepada rakan-rakan. Okey, bukan saja fizik sains pun ada, belajar inertia, boleh share juga pada kawan-kawan yang ambil mata pelajaran sains. Okey, supaya kita dapat sebarkan ilmu dan juga beroleh kebaikan di atas perkongsian tersebut. Okey, sebelum tu cikgu boleh share link sijil link sijil akan diberikan sebagai tanda terima kasih cikgu kerana kehebatan kamu menyertai kelas tuition percuma pada hari ini. Okey. Okey, link sijil dah ada. Okey, boleh dapatkan pada ruangan chat. Okey, sila ambil perhatian, link tersebut akan tamat dalam tempoh setengah jam selepas live ini. Pastikan anda login dengan email e-didik, MOE, MyGuru dan MyJawi untuk membuka link berkenaan. Okey, jadi sebelum kita tamatkan kelas pada petang ini, cikgu nak mempersilakanlah Cikgu Yani untuk memberikan sepatah dua kata. Silakan.
Okey, terima kasih kepada semua penonton pelajar kita, guru-guru yang sentiasa setia bersama kita sehingga di akhir rancangan kita ini. Okey, di kesempatan ini saya ingin mengucapkan selamat Hari Guru kepada semua guru-guru yang berada di sana, di luar sana, di sini dan di merata-rata tempat. Selamat Hari Guru dan itu sajalah. Teruskan.
Okay. Okey, terima kasih Cikgu Yani. Betul juga Cikgu nak ucapkan selamat Hari Guru kepada semua cikgu-cikgu terutama yang berada di konti, Mr.Peh dan Cikgu Yani. Semoga usaha kita ni mendapat manfaat lah, dapat memberi manfaat kepada semua murid-murid dan rakan-rakan guru yang mungkin memerlukan kita punya bahan di YouTube. Akademi Youtuber banyak sangat membantu kepada rakan-rakan guru dan juga anak murid semua untuk buat ulang kaji. Tuition percuma je. Boleh boleh pause, boleh play semula, tak faham boleh tanya ataupun PM pada cikgu-cikgu Akademi Youtuber melalui Telegram. Okey, jadi cikgu nak ucapkanlah terima kasih kepada semua penyokong Akademi Youtuber. Doakan kami terus kuat dan bersemangat untuk membantu dalam membangunkan pendidikan Malaysia. Okey, lupa pula cikgu nak cakap, minggu depan bersama cikgu pada hari Jumaat untuk fizik tingkatan 5 untuk tajuk tekanan gas pada hari Jumaat 9.30 malam bersama cikgu. Okey, jadi itu saja. Mungkin depan hari Ahad dengan Cikgu Hasnitah kan? Mr.Peh?
Ya. Ya,
dengan hari Ahad dengan Cikgu Hasnitah pula. Okey, sebelum kita cuti sekolah seminggu. Okey, itu saja daripada saya. Assalamualaikum warahmatullahi wabarakatuh. Bye.
Bye.
Semua sekolah ditutup hingga cuti akhir tahun 17 Disember 2020. Anda tak cukup bahan? Tak ada rujukan? Tak faham? Anda nak tuition tapi PKP? Jangan risau, kami di Akademi Youtuber dengan kerjasama Kelab Guru Malaysia dan e-Didik Malaysia mengadakan kelas tuition online. Semua peringkat ada, semuanya secara percuma. Video PDPC pun ada. Apa ditunggu lagi? Layari www.akademiyoutuber.com. Dibawakan kepada anda oleh Akademi Youtuber.